In this video we're going to talk about exponents and square roots. So let's start off talking about exponents. Let me give you an example of an exponent and what it means, and then we'll do a little vocabulary. So let's say you see something that looks like this. 5 with a little 3 in the upper right hand corner. The way you say that is 5 to the third power. And what it means is 5 times 5, oh that's a 3, 5 times 5 times 5. So this number right here, the 5, that's called the base. And the little number up here is called the exponent. Let's write that down. So this number here is called the base. And the little number up above is called the exponent. The exponent tells you how many times to multiply the base by itself. So the 3 comes into play because there's 3 5s there. And then you could actually, work it out. 5 times 5 is 25 times 5 is 125. At its core, an exponent is a shortcut way to write multiplying by a certain number when you want to multiply by that number over and over and over again by the same number. Let's look at another example. What if we have a 2 and then we have a 5 up here? Okay, what is that telling us to do? Well, first of all, remember how we say that. 2 to the 5th power. You say your base first, and then you say to the whatever power. 2 to the 5th power. The first one we did, 5 to the 3rd power. 2 to the 5th power. That means we're going to write 2 5 times. 1, 2, 3, 4, 5. And we're going to multiply. I'm using a dot to mean multiply. I'm not going to use x because we're going to start using x for variables. And you kind of get away from using x for multiplication once you start pre-algebra and algebra. So I got 2 times 2, that's 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th power is 32. Well, we could also do this with fractions. I know, fractions are your favorite. What if we had 2/3, the whole thing 2/3, to the, let's go 4th power. Now, it makes a difference here that I've got the 2/3 in parentheses. I'm going to erase this in a second, but if I didn't have the 2/3 in parentheses, let's say I just had it like that, then what that would mean would be 2 to the 4th power over 3. You wouldn't be taking the whole thing to the 4th power. See the difference? Actually, I'll leave that one up there and we'll do that separate so you can see how the answers are different. So let's work this way then. 2/3 to the 4th power means 2/3 times 2/3 times 2/3 times 2/3. 4 times because it's to the 4th power. To get the answer when you're multiplying fractions is really straightforward. You just multiply across the top for your numerator and multiply across the bottom for your denominator. 2 times 2 is 4, times 2 is 8, times 2 is 16. That's right. Now on the bottom, 3 times 3 is 9. A little shortcut here that you might like to do instead of just going 3 times 3 times 3 times 3. You could group your 3's together in your mind. Like, okay, I got to take 3 times 3, that's 9, and 3 times 3, that's 9. So basically you have 9 times 9, which is 81. That might be a little easier way to do it if you know your multiplication tables. Otherwise, you're going 3 times 3 is 9, times 3 is 27, times 3 is 81. For some of you, it might be more difficult to do 27 times 3 in your head as opposed to 9 times 9. You can always group those numbers together. We could have done the same thing in the top. We could have grouped these 2's together to get 4, and these 2's together to get 4, and then multiplied those to get to 16. When you're multiplying, it doesn't matter what order you multiply in, so that's why that works. Now on the other one where we did not have the fraction in parentheses and we would have only multiplied the numerator, we would have only taken the exponent to the numerator without those parentheses, that's what it means. There's a difference there. You need to pay attention whether there's parentheses or not. So in this case, you'd have 2 times 2 times 2 times 2 is still 16. and then you just have the 3 in the bottom because that didn't get taken to the 4th power. You can also do exponents with decimals. If you have 5.2 to the 2nd power, that means 5.2 times 5.2. In this case, I'm using parentheses to mean multiply, and I'm doing that so we don't get confused with the decimal. This multiplication up here where I use the dot, you try to put it so it's not down on the line, otherwise it looks like a decimal. You try to put it up, but it would be a little confusing. You know, that's a lot of dots, so makes it less confusing to use parentheses when you're doing decimals. That's why I do it that way, and you may find your instructor does it that way as well. To figure this out, we just need to do the multiplication. Might as well do it. Let's practice multiplying with decimals. Remember, when you're multiplying with decimals, you ignore them, and you just do the multiplication like it was 52 times 52. 2 times 2 is 4. I'll do that. 2 times 5 is 10. Then we move over 1. 5 times 2 is 10. Carry the 1. 5 times 5 is 25. Plus 1 is 26. Add, 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 add. And then, little review, however many digits are to the right of the decimal is how many places we move that decimal over from the far right hand side. The final answer here would then be 27.04, which makes sense if you're using your estimating skills. 5 times 5 is 25. So 5.2 times 5.2 is going to be a little bit bigger than 25. 27.04 makes perfect sense. Let's try one with negatives. I'm going to have to erase some of this. We got positives, fractions, and decimals so far. You can also use exponents on negatives, or with negatives as a base. For example, let's do, now I'm going to put this in parentheses to say I'm taking the whole number, negative 5, to the 2nd power. That means negative 5 times negative 5, which would be positive 25. Same procedure, you just take that number in the parentheses and you times it by itself, whatever that is being taken to that power. You might hear this word, so I'm going to go ahead and mention it. Whenever you see to the 2nd power, you may hear squared. I could read this as negative 5 to the 2nd power or negative 5 squared. Squared is a shortcut to mean to the 2nd power. Let me show you why. We'll do another one squared, except I'm going to do a positive one. Say I have 7 squared. I don't have to use a parentheses when I don't have a negative. 7 squared. Remember what that is? It's not 14. 7 squared would be 7 times 7, which is 49. And why the word squared is in there has to do with this little guy here. If you have a square and you know that each side is 7 units, say it's 7 inches or 7 feet or 7 whatever on each side, because the square has all equal sides, the way you find the area of the square is to take the length times the width, which in this case the length and the width are the same. 7 times 7 would give you the area. What's a shortcut way to write 7 times 7? 7 squared. The way you find the area of any square is to take the side and square it. For example, let's do one more. Let's say I had a let's draw a square. If I can draw a nice one, that's pretty good. If I knew that the side of this square, let's get all algebra on you here and see how you do. If I knew that the side of this square was x, and this side was x, and this side was x, and this side was x, I could say the area is x times x, which is x squared. If you don't get that algebra part, that's okay, but I kind of wanted to let you know why you would hear the word squared. And while we're at it, there's another exponent that has a shortcut word, and that is to the 3rd power. If you see something like this. We'll get back to these negatives in a minute. I haven't forgotten. Let's say you see something like 2, I keep doing that, 2 to the third power. A shortcut word for that is cubed. You may hear somebody call that, or read it as 2 cubed. When they say cubed, that means to the third power. And there's a similar reason for that. And it has to do with this shape, which is a cube. If I know that this cube is 2 feet wide, 2 feet long, and 2 feet tall, the way you find the volume of the cube is 2 times 2 times 2, which is basically 2 to the third power, or 8. And that's why it's called cubed, because it has to do with finding the volume of a cube. While we're talking about that, let's throw this cube in here. I found some interesting cubes while I was looking for cubes. That one's kind of neat. If I wanted to find the volume of this, let's say each one of these little cubes in the corner, the little corner cubes, like these little sugar cubes here, was 1 cubic centimeter. Each one of those little things is 1 cubic centimeter. And so that would mean that this distance along here is 1, 2, 3, 4, 5 centimeters. And this distance would be 5 centimeters tall, and this distance would be 5 centimeters deep. How many sugar cubes would it take to create this shape? How many of these little cubic centimeters right here, these little blocks make up a cubic centimeter? How many of those would it take to stack up to make this whole thing? Can you picture it? How much on the bottom row? 5 by 5. How much on the bottom level? 5 times 5, 25. And then you need 5 stacks of that. So how are you figuring that out? 5 times 5 times 5. 5 to the third power. 125 cubic centimeters is how you write that. So it would take 125 of those little cubes to make this. That's one application of exponents. I think, let's do one more -1, and then we're going to have to save square roots for another video, which is fine. Let's do one more -1 so you can see an example of that. How about a negative fraction? That sounds exciting. -1/2 to the 4th power. Now don't get freaked out. Just remember what it means. What does it mean to take it to the 4th power? It means -1/2 times -1/2 times -1/2 times -1/2. How do you multiply fractions? Straight across the top. That's not too hard. 1 times 1 times 1 times 1. Don't say 4. 1 times 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. What about the negatives? Let's see, I got 4 negatives here. Negative, 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 negative. I could go through this and go, a negative times a negative is a positive. Then times a negative would be a negative. Then times another negative would be a positive, which is the correct answer. It's a positive. But an easier way to look at it is to pair them up. You know 2 negatives multiply together to be a positive. So these 2 red negatives would multiply together to be a positive. And then we could think, well, these 2 pink negatives would multiply together to be a positive. Therefore, the answer will be positive. And as a matter of fact, if there are an even number of negatives, then the answer will be positive. And there's an even number of negatives when this exponent is even. Let me write that out for you so you can write it in your notes. You'll play with it a little bit when you do some problems. You'll start to see the pattern. But you might want to write this in your notes. Let's say you have a negative number, any negative number, to an even power. That's going to come out to be a positive number, because all those negatives are going to pair up like these red ones. If there's 6 negatives, they'll all pair up, and they'll all sort of cancel each other out. That's not exactly the correct terminology, but they'll all pair together to make positives. If you have a negative number to an odd exponent, you're going to have one poor guy left over, and so your answer is going to end up being negative. Like if we had, say we had this negative 1/2 example only to the, let's go to the 5th power with it. So I'd have all these, and I'll do this in blue to show you that I'm adding this guy on. I have all those, but this guy gets thrown in right here. Now I've got 5 of them. Let me get rid of the answer so we don't get confused. So this problem matches up here. So now I got to the 5th power. Well, these 2 red ones went together to make a positive, and these 2 pink ones went together to make a positive. But this blue negative over here, he doesn't have anyone to, pair up with to be a positive. He's left all by himself, so that makes the answer negative. We still got to figure out the numbers. 1 times 1 times 1 times across the top is still 1. And on the bottom, we've got, these were 16, right? Remember, 2 times 2 times 2 times 2 is 16. Times by 2 one more time would make 32. And then in my mind, these pair up, that guy's left over, so it'd be a negative 1 over 32. Any negative number to an odd power is going to be a negative. Well, I hope that was a good introduction to exponents. And we'll do square roots in the next video. I have to show you this one picture, though. I found this when I was looking for pictures of cubes. What do you think of that? I guess I found this article, and these Japanese farmers found a way to make watermelons in the shapes of cubes. I guess it makes packing a little bit easier, doesn't it? A little easier to calculate the volume. Just like we talked about, length times width times height, they can fit it in these boxes. It becomes easier to pack, less waste. It looked kind of clever. The way they said they did it was putting the seeds or the small watermelons into a glass container or a plastic container and then forcing them to grow in that container, and they grew that way. It's pretty interesting. Well, hope you enjoyed this video, and look for the next video on square roots or whatever else you need help with.